Some people find true love the first time they go looking. For others, they have to try a second time. But is it true that by the third time you are guaranteed to find true love? Well, that's what we're testing here today. So I have 8 cards that spell out true love. So what we're going to do is we're going to use a very, very special shuffle. It's called the under-down shuffle. It's a cousin to the Australian down-under. So how this works is we will move one card to the bottom and then the next one goes on the table and repeat that. And we'll do it by repeating the phrase, she loves me not. Okay, so this is how it works. She loves me not. She loves me not. She loves me not. Yes, no, yes, no, yes, no, yes, no, yes. That's looking promising. Okay, so did we find love on the first try? I don't think so. I don't even think that's an English word, no matter how you kind of group the letters together. Okay, so I think that's a fail. That is a failed relationship there. Well, let's try a second time and see if we do any better. She loves me not. She loves me not. Yes, no, yes, no, yes, no, yes, no, yes, no, yes. Did we find love the second time around? I don't think so. I don't see true love hiding in there. Okay, but the claim here is that by the third time you are guaranteed to find true love. So let's test it here. She loves me not. She loves me not. Yes, no, yes, no, yes, no, yes, no, yes, no, yes. Did we in fact find true love this third time around? I believe we did. Look at that. We have just confirmed the claim that third time's true love. Okay, so let's talk a little bit about the mathematics here. Now, of course, you don't need cards that spell out true love. They just happen to spell out the name we've given to this effect, and they happen to have a total of 8 letters in those 2 words. Okay, so that's why they were chosen. So let's take a look at this, and we won't go very deeply into the mathematics, but I do want to go some way into it so that you can make use of this for other situations. Okay, so what we have here is I have an ordered packet so that we can kind of follow what's going on. Now on my channel I have examples of what are called false shuffles, false mixing routines. So these are different ways that you can mix the cards, and it looks like you're randomizing them when in fact you're leaving them the way they are. Okay, so maybe just to show you a couple of those that I've talked about in other videos, and then we'll kind of relate it to this one here. One that I've shown already, which is very powerful, it's called the first shall be last and the last shall be first. Okay, so how this shuffle or false shuffle works is you begin dealing out the cards until the spectator says stop. So maybe they say stop there, and then you go on to another pile. Maybe they say stop just right there, and you go on to the next pile. Maybe they say stop there, and then you deal out the rest. Okay, so the first shall be last. The last, these are the last cards drawn, shall be the first ones to pick up. last shall be first. Okay? Now it ends up that if you perform this shuffle a second time, it constitutes a, quote, false shuffle. So let's go ahead and do it. And you can choose different stopping places. That is the amazing thing. So I'm going to deal out until you or the spectator says stop. Maybe they say stop right now. That's different than the last time. And I'll deal out. Maybe they say stop now. Maybe stop now. Okay. So the first shall be last, and the last shall be first. Okay. So the claim is that that mixing has brought the packet back to its original order. And has it done that? It has indeed. Okay? So that first shall be last and last shall be first. Each one of those just reverses the order of the cards. So you do it twice and you get back to the original order. So those two taken together, two of those shuffles of first shall be last, last shall be first, constitute a, quote, false shuffle. Okay, they'll leave the packet alone. Another powerful one that we've shown you on this channel involves something called hypercoding. Hypercoding. Now you don't need to remember that name, but the way that we applied it was that if you have a packet of 8, 9, 10, or 11 cards, here I have 8 cards, if you spell out any of the 52 card names twice, those two sets of actions constitute a false shuffle. That means in the end, you'll get back to where you started. Okay, so if you ask the spectator to choose any card from the deck, maybe they'll say Queen of Spades. Okay, so if you spell out Queen of Spades twice, that will indeed constitute a, quote, false shuffle. So Q, U, E, E, N, O, F, S. So we need to finish spelling spades. So we spelled S already. P, A, D, E, S. So that is Queen of Spades spelled once. We'll spell it a second time. Q, U, E, E, N, O, F, S, P, A, D, E, S. Okay? And so what we showed in a previous video is that this is also a false shuffle. Performing those sets of actions twice brings the packet back to its original state. Okay, now returning to our very special new shuffle here, the under-down, let's see what happens. So let me just confirm once again that we have a packet in sequential order, A's through 8. So if you perform this, she loves me not, she loves me not, yes, no, yes, no, yes, no, yes, no, yes, no, yes. So that's performing it once, okay? So do we get anything kind of orderly from that? So look at the mess here. We have Ace 5, 7, 3, 8, 6, 4, 2, okay? Certainly not back in order. So if we do it a second time, where does that take us? She loves me not, she loves me not, yes, no, yes, no, yes, no, yes, no, yes, no, yes. Where are we now? Are we looking at anything all that nice as far as an ordering for the cards? We are not. That is quite a mess, okay? But if we do it a third time, we are guaranteed to return this packet to its original state. Now, if that's true for all packets of size 8, then what we have discovered is a powerful false shuffle for 8 cards. And you can use this anytime you have a packet of 8 cards. So let's check it here. We have to perform this she loves me not shuffle one more time. She loves me not. Yes, no, yes, no, yes, no, yes, no, yes, no, yes, no, yes. Did we return the packet to its original order? We did indeed. Okay? So in mathematics, we say that 3 of these shuffles is equivalent to the identity, permutation. A permutation is simply a rearrangement of a set of objects. Here, each time we perform this she loves me not shuffle, it permutes, it rearranges the cards, but by the 3rd time, you're guaranteed to return the cards to their original order. Okay, isn't that amazing? Now, we've shown that it works for packets of size 8. It does not necessarily work for other packet sizes. In fact, it will not work for most other packet sizes. My conjecture is there are very few packet sizes for which performing this special shuffle 3 times returns the cards to their original order. But it does in fact work for a packet of 8 cards, which is wonderful. Okay, so that's a glimpse into the mathematics. This under-down dealing, when performed 3 times, returns a packet of 8 cards to its original order. Now you might wonder, well, who cares about that? Well, anytime you mix cards in a way that leads the spectator to believe that the cards are mixed, sufficiently mixed or randomized, but they're not, you are in a very strong position. So for example, performing that shuffle 3 times as we did, most spectators would assume the cards are in some unknown state. Well, guess what? They're not. You know that 3 of those shuffles constitute the identity permutation, which simply means the cards are left alone, or in other words, returned to their original order. Well, wow, if you know that this is back to the original order, then you know everything about the cards. You know what the top one is, the second one, the 8th one, the 5th one, and so forth. Okay? So at this point, what you could do, there's countless things you can do with your knowledge here. You have complete knowledge regarding this packet of cards. Complete knowledge. Okay? And you only have that because we've performed a set of actions that in the end preserve the original order of the cards. So what you could do is just have the spectator freely, randomly choose any one of the cards. And you just note where they pull it from. So maybe, for instance, if they grab this one right here, they freely choose that one. You can see that that is the 5th card. The 5th card. So they pull that out as their special card. And then these cards can be set aside and not used further if you would like, or you could use them further if you would like. If you would like to hide the fact that these are ordered, what you can do after they've pulled out their 5 of hearts, now they don't know that you know it's a 5 of hearts. You can just casually mix these while speaking with the spectator as if you're just kind of doing it out of habit. You're just kind of mixing the cards up a little bit as you're thinking through, I wonder what card you've just randomly chosen. After we mix the cards thoroughly with this she loves me not shuffle, and you randomly chose one, let me think. And so you can just kind of claim that you're kind of fidgeting here with the cards as you're pondering. You're trying to divine the identity of this card. Now you can set these aside because you have covered your tracks. You've destroyed all order. There's no more order left that would allow the spectator to figure out, how did you know that they chose the 5 of hearts? Okay? Okay, so if you set this aside, there's no hope for them to be able to deduce the method at all here. Okay, and so they look at their card, right? And they know it's the 5 of hearts. And so you look deeply into their eyes and try to discern the card value. Now, since they're all hearts, you know the suit, of course. So you're trying to figure out the card number. Well, you could play with them in a number of different ways. You could say, well, is it a number smaller than or equal to 4? And see if, maybe they give away something in their facial expressions, a smile or something to give you some clue as to whether or not that's true. Now, you know it's a 5, but you can use this as the basis for supposedly reading their facial expressions or their body language. You can also point out that, well, to randomly guess their card correctly, there's only a 1 out of 8 chance of doing that. So it's less likely than rolling a die and calling ahead of time what it's going to come out to be. It's like rolling an 8-sided die, okay? So not very likely, okay? It happens, about 12% of the time, 12.5% of the time, but that's not very likely. So at some point, maybe after some pretend concentration, you can say, oh, I know. I'm getting a clear impression of what card value you chose. I'm confident it's the 5 of hearts. And most likely they're going to kind of perk up and go, how in the world did you guess that correctly? Now, there is a chance you guessed it correctly, but that probability is quite small. So anyway, that's just a kind of a simple example of if you have complete knowledge of the structure of a packet of cards, wow, boy, does that put you in a strong position, okay? When the spectator actually thinks that the cards here are just randomly mixed up, okay? So anyway, I just wanted to show you that fun little result that if you perform the under-down 3 times on a packet of 8 cards, it returns it to its original state. Okay? So just think through how you could use that. What kinds of packets of 8 cards could you begin with and then use this little principle? Okay? I just thought of another application on the fly right now while recording. What you could do with this is you could show the cards to the spectator. Now here they don't have to be in order, but you can show them in order first just to kind of clarify that you actually have 8 through 8. You can give this little packet to them, okay? And then you can have them mix these as much as they would like. Okay, and then have them take a photo, to a picture. Okay, now maybe your back's turned and that kind of thing, but just have them lay out the cards like this. They're across the table from me here, and have them take a photo of that, just a picture of the order in which they arrange the cards before mixing. Okay, now once they've done that, they can gather the cards, turn them over so you don't see the faces of the cards, and hand them to you. Okay? And now at this point, you can claim that using this very special shuffle, it will enable you to know the exact ordering that the spectator put the cards in. Okay? This special shuffle is going to enable you to do that. So all you would do is you would just do the under-down shuffle. So this is another way to do it. Instead of using the phrase, she loves me not, you can just use the original words, under, down, 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 and then set the last one on top. Now, if you do that shuffle 2 more times, you'll return the packet to the original order that the spectator just put the cards in. Okay? So if we were to do it a total of 3 times, what that would mean then is when we look at the cards, we don't have to show the spectator that we're kind of what we're seeing. We can kind of go like this. You can, from here, actually read off the exact ordering of the cards in the photo that the spectator took of their arrangement of these 8 cards. Okay? Because, whatever's here on the first will be the first one for theirs and so forth. So try that out. Now you'd have to perform the under down 2 more times, right, to get back to the original order that the spectator just put the cards in. Okay. So anyway, I thought I would share that with you. It's a fun little result that I discovered while creating the Hidden Structures online course. It's a powerful little false shuffle for packets of 8 cards if you perform this under-down deal exactly 3 times. So have fun with that and see if you can discover other false shuffles, other false mixing routines that if you perform them either once or twice or maybe 3 times, you'll get back to the original ordering. Now it is nice to perhaps keep the number of times needed smaller than or equal to 3 if possible, just because the tedium of performing something 4, 5, 6, 7, 8, 9 times, it's going to put the spectator to sleep. That'll just be too many. Okay? So find a false shuffle that you can do in 3 or fewer times, and then you'll have a surefire way of supposedly randomizing a packet of cards in the minds of the spectator where you actually leave the cards in their original order, which gives you complete knowledge and control over what follows next. So thank you for watching.